Another co-benefit of reducing SLCPs is, of course, the climate justice aspect, which is implied when we say food security, sea level rise, and health impacts improving from reduced SLCPs. Just to remind ourselves, the disparities that we talked about are still about this issue of the top 50% of the richest population, top 10% of the population that is richest, emitting almost 50% of the total lifestyle consumption emissions. So here is the population arranged by deciles, income deciles, and these are the emissions. And the bottom 3 billion people, the poorest 50%, are responsible for only about 10% of the total lifestyle consumption. Obviously, the reduction in SLCPs is going to help a lot with climate justice and evening out the disparities, the impacts, and so on. Okay, this is the idea of showing how the probabilities of warming are going to depend on the action, especially in terms of energy intensity compared to 2010 for various scenarios and the resulting warming with some probability, because there is always details such as feedbacks, for example, that I'll mention in a second. So you cannot just say we will reach 2 degrees centigrade or 1.5 degrees centigrade. There is a probability of, let's say, 66% probability of reaching 2 degrees or remaining below. Doesn't mean we will hit 2 degrees and remain there. We may overshoot and come back. The question is, how long will we overshoot? How quickly will we come back, and so on and so forth. So it's better to talk about these in terms of probabilities. Okay, so here is the 4 blocks and 3 levers that we have talked about, that business baseline or business as usual is compared against. So you can stay in the safe zone of 1.5 degrees C or less, but you will have a long tail. The probability of overshooting is not small. Okay, so this whole tail here extends all the way to over 4 degrees centigrade, even though probability of that is low if we do all these things. Okay, so baseline with climate intensity or energy intensity reducing by 80% with respect to 2010 is going to get us here in the range of 4 degrees with a really long tail out to 8 degrees. Reducing the energy intensity by only 50% with respect to the baseline is going to give us much higher expected warming with tail that's again very fat and very long. If you include carbon feedbacks with this calculation of 50% energy intensity reduction, then obviously you will shift the warming, and there is, you can see the peak is reduced in terms of the probability, but that those calculations have some uncertainties, which is reflected in the spreading of the probability of warming ranges. So here you are still beyond 8 degrees, but if you hit 8 degrees, we're going to be in very deep trouble in any case. And these are called existential threat regions here. Catastrophic here in terms of many events, tipping points, and so on in the system, like collapse of the Amazon, collapse of maybe Antarctic ice sheets, Greenland melting away, thermohaline circulation shutting down and creating lots of problems. And dangerous, of course, includes all kinds of species like corals disappearing and so on and so forth. So black carbon and methane mitigation measures then include these various options. The colors here are related to costs. Either they are, so in the green color here, for example, blue indicates minimal cost or cost saving, Green indicates moderate costs, orange and yellow indicate high costs, and gray indicates hard to estimate the cost. So it's good to have an idea of the cost involved so that you can look at the discounted present value of the investments into these mitigations. Okay, so improved stoves, this is percentage of the total reduction again. Oil and gas, waste treatment, other low-cost black carbon and methane reductions, coal mines leakage or capture, other mid-costs ranges here, diesel particle filters and so on that we have looked at already, agricultural waste burning and so on. So again, the main point is these are achievable without any new technology innovations. So if it's all so hunky-dory, then why is there still not as much action as one would hope for? Obviously, this was taken note of by the United Nations Environment Program, and in 2012 it set up the so-called Climate and Clean Air Coalition. The Climate and Clean Air Coalition is a global organization of governmental and non-governmental and intergovernmental entities that have committed to improving the air quality through actions that reduce SLCPs. Okay, this is consistent with our solution number 9. This is here 40, 80, 100. We talked about before 50, 90, 100, I think, but anything is good at this point. So here, for example, CCAC countries contributed about 40% of global black carbon emissions, and CCAC countries could supply about 50% of the total mitigation by 2030. So Climate and Clean Air Coalition's activities target the main sectors responsible for SLCP emissions like cooking, heating, industry, transport, agriculture, fossil fuels, waste management, refrigeration, and cooling. So it currently focuses on 11 initiatives. 7 are sector-specific initiatives that include diesel, oil and gas, waste, bricks, HFCs, household energy, and agriculture. So you can see that HFCs are included in there. The remaining 4, which include supporting national action and planning, assessments, finance, and health, cut across sector lines to reduce emissions of all SLCPs. So there is a finance system set up which apparently is working. This is the timeline of the CCAC's celebration of 5 years in 2017, which I'm not going to go into, but we'll come back to CCAC a little bit later on. But as you have seen already, many of the figures I'm using are actually from CCAC. So in terms of providing beautiful graphics that are easily comprehensible by lay people, are produced by CCAC, which obviously should help decision makers, governments, policy makers, non-governmental organizations, and any entity that's is interested in reducing SLCPs in general and climate change at large. Plus also great for education, like I love using them in my podcasts, right?